No, the girl remembered me, and I was like, I used to play soccer with you.
Cynthia, pull out the hall.
So funny.
Well, what proof do you have? What if I had to?
Well, we have a test Thursday.
Nobody has
Yeah. And I have an AP exam on Wednesday, so I'm just gonna go straight.
No, do that again.
Like, this is disgusting. And then I have AP World next month. I didn't take it. Tomorrow, or today's my last day. I'm in AP test.
I'm gonna miss all my residents. I'm gonna miss Susan, I'm gonna miss Ronnie, I'm gonna miss Sarah.
Okay, if you're not sitting with them right now, sit with the lab partner who you're going to work with tomorrow, ladies and gentlemen. If your lab partner is not here, it's okay to sit on your own, but you're going to have to do all the work today for them. So here we go, ladies and gentlemen. Yes, this is your quiz.
Oh, actually, I popped off on this one. See, it works a lot better when you don't calculate molarity. It works a lot better when you don't calculate. We were talking about it before. I read it. Because, like, we were like, hey, molarity is not grams over liters. Yeah.
Awesome.
I had a stroke last time.
This is not even F. It's F, but don't even look at it. Same with that. That isn't F. It's gonna be up to
5, 6, 7, 8, 9, 13, 14.
and I got 2B. Like, this is the worst I ever thought. Like, this is the worst I've done.
I don't know where that I think that like the whole thing was 21 points, but he only counted 20.
Correct. They could have gotten 21, but I only counted 20. All right, ladies and gentlemen, let's take a look at this.
Because there's just like so many variables, like one part you get.
1, 2, 3, 4, 5, 6.
Bro, I don't know. My last lab, everyone.
Sophia, what can I do for you?
Everybody was.
This has 6 out of 7 issues. You don't actually.
If I pulled up in class,
Yes, could you do that?
I'm trying to literally
Still leaders into leaders, things like that. You need to show a conversion of your
I did think that one.
All right, ladies and gentlemen, so here we go. Let's take a look at the answers. That ain't it. No.
That I got. But literally, I was so.
yeah, because I love you be slow.
But like, I literally don't know how. I don't know how. I just guess. To be honest, I just guess. I take it everything.
All right. Here's version A and version C, ladies and gentlemen. I will put version B up there in just a minute. Okay. Here's your balanced equations for each, ladies and gentlemen. So that was worth a total of 6 points. 1 point for each of the compounds that you wrote, 1 point for balancing it, 1 point for including the states. Taking the grams, getting it into moles, that's 2 points. Using the correct ratio, that is 1. Getting the correct answer there, 1 point. That answer then comes into this calculation, 1 point for choosing the correct R value, 1 point for correct temperature in Kelvin, 2 points for your final answer here and there, ladies and gentlemen, for a total of 14 questions. Questions, ladies, gentlemen. For problem number 2, I gave you a balanced equation already. Started out with molarity, took the moles, converted it into, milliliters, converted it into liters times molarity, times the ratio, gave you the moles here. Took that moles, used formula mass over 1 mole to get to your answer, ladies and gentlemen. 2 points for your final answer and the correct number of sig figs with the correct unit. There's A and B question, or A and C questions. If you had version B, there is your answers, ladies and gentlemen. Okay? So again, balanced equation, going from grams into moles, ratio, answer in moles, taking and putting it into PV equals nRT, a point for the R value, a point for the correct temperature. Then your units, ladies and gentlemen, your final answer in the correct units and sig figs. Taking your volume, putting it into liters, times the molarity, times the ratio. Now, if you did not show me this and you went right into this next calculation, I did still give you that point. You didn't have to stop there, but I gave you a point for getting that part correct. Then, ladies and gentlemen, times the mass over 1 mole, final answer in sig figs. Questions on any of that, ladies and gentlemen? Okay, take out a calculator, get a sheet of paper out, ladies and gentlemen. If you want one, there is one up here. And open up your computer.
It's okay.
Now, I'm telling you right now, it would be wise, ladies and gentlemen, for you to do these calculations on a sheet of paper because you're going to need them for your lab that you are going to do. So if you do them now, which you need to do because we need all this information before we begin the lab, you will have them already set for the post-lab. You are getting a card, ladies and gentlemen, you and your partner. I'm assuming the person that you're sitting with is your partner for the lab. That card, ladies and gentlemen, you need to make sure that you mark down what color you have so that tomorrow you go to the correct lab station. The lab station that you will work on, ladies and gentlemen, is based on the color of your card. Okay.
I'm so hungry.
I don't know.
Depends
on how many people we have here. If there is not,
That reminds me of
not
the
that number notes, then you're going to have to split up.
I have to look at it.
Yo, I
Usually,
see.
when I work, she washes my uniform. If I work the next day,
Here's the thing, I will give you one tomorrow. If there's not another person here, I will.
We got shit to this.
stay up there.
And then I will rock, paper, scissors, or whatever, see who moves into the other. Okay,
Like,
good.
let's go.
There you go. All right, ladies and gentlemen. All the cards, ladies and gentlemen. On the top, you have a certain volume of NaI, sodium iodide, that you are going to use in tomorrow's lab. It is different depending on which card you have. On the bottom is the amount of lead nitrate you will use. That is the same for every group. So, ladies and gentlemen, here is what you are going to do first. You are going to answer these three questions. Here's the balanced chemical equation, already written out for you. You are given 10 milliliters of 0.5 molar sodium of lead nitrate. You need to calculate three things. Number one, the moles of lead nitrate. Number two, the moles of lead iodide that would be produced. And number three, the grams of lead iodide that are produced. Yes?
Is it the same formula for everyone? Like, is that everyone's formula?
Everyone has that same volume. Everyone has that same molarity. Yes. Okay? Now, this is your first calculation. Let me show your second. Same formula, ladies and gentlemen, but now you are going to calculate three things again based on your volume of sodium iodide. Your volume. Okay? So one group has 5 milliliters, one group has 10, one group has 15, one group has 20, one group has 25, and one group has 30. You will use your volume here. And again, I need three things. I need the moles of sodium iodide that you begin with. I need the moles of lead iodide that you could produce from this. And I need the grams of lead iodide that you can produce from this, ladies and gentlemen. So right now, between you and your partner, you need to get these two sets of calculations done. Excuse me, Mr. Brand. Sure, will do. Bye. Leave down to student services. So, let's go. Get to work, ladies and gentlemen.
Slides posted on Google Classroom.
These are not. It would be in the daily agenda in your in Google Classroom under the daily agenda for today.
Okay, thank you.
Actually, this might be under last Thursday because that was the day we were supposed to do the lab instead of today. Let me check. Okay, thank you. It's last Thursday that you would find it under those two slides.
They're all videos.
The one up above is not a link for a video, it's the link for the daily agenda. Click on the date, not where it says video, on last Thursday. It was made last Thursday, by the way.
Oh, last Thursday, so the second.
Why didn't you know?
But we all have 10 milliliters of iodine.
You all have 10 milliliters of lead nitrate. By the way, this is what we are about to fill out, ladies and gentlemen, this table right here. Now, again, we're doing this as a group. You don't pull your weight. You don't calculate your stuff. Somebody else is going to have to do your calculations for you. So we're trying to get this all together so that you have all of this information for your lab tomorrow. So you are asked to find the moles of sodium iodide and the moles of lead nitrate based on having your volumes here. Then we're going to find the moles of precipitate that we create and the grams of precipitate that we create. And then tomorrow you're going to do the lab and we're going to actually get the numbers here. So this is what we got to fill out today, and I got to show you how to do the lab. So let's get to work, ladies and gentlemen. If you calculate these three things for this and the three things on the last slide for the lead nitrate, you will have everything you need to fill out that table. Okay, let's go. Gotta get to work.
The ratio, this is the number of moles, right?
No, the number of moles is always in front.
And it's already balanced out?
Yeah, because we're
Yes,
looking for
the
how
one
many
that I gave you is already balanced up
So
there.
then
Yep.
we multiply that by the similarity.
That's the one that's balanced.
And then you put 1 meter.
The only time you need a formula mass is when you're going to grams of lead iodide, ladies and gentlemen. You are given a molarity and a volume. You should be able to calculate the moles of sodium iodide and the moles of lead nitrate with the molarity and the volume. Then you need the ratio step to figure out how many moles of lead iodide you would create, both from the lead nitrate and the lead iodide. Why do we need to find for both?
To figure out which one's limiting.
Thank you. Excellent work. We're going to figure out which one is limiting.
So do we have to do the calculations for the PBNO3?
Yes, you need to do it for both.
But that's not on there.
That was the last slide that I showed you. So you need to do these 3 calculations for the NaI, and you need to do the 3 calculations, same 3 things, for the lead nitrate. But the second one, you are doing your volume of NaI. Everyone has this volume of lead nitrate.
Can you go back to the other slide?
You certainly bet I can.
What is the number beside?
The number beside.
Because lead can be +2 or +4. So is it?
But it's already written in balance for you.
Okay, so it's +2.
Yes, it is. The only time you would need to know that, Ava, is if you had to write the compound from its name. This is already done in balance for you. Everything is there.
Wait, this is 0.0.
Where do you write what? What do you mean, where do you write it? They're both based on this formula. You're given 10 milliliters of 0.5 molar this stuff. And you're given, you guys have 10 milliliters of 0.5 molar this stuff.
You want us to write that under?
No, I want you to calculate those 3 things. I want you to calculate how many moles of sodium iodide you are going to have. Then I want you to calculate how many moles of lead iodide would be produced from that. And then finally, how many grams would be produced from that. Those 3 things. That's what we've
Did I
been doing.
get the first slide right? I think I did it.
Moles of lead 2 nitrate. Are you talking about the numbers?
Yeah.
Well,
So we're 0.
I mean, I don't have the calculations off the top of my head.
Because this would be the moles for this.
Yes,
right?
it would, yeah.
And then this would be the moles.
After the
for
ratio,
this.
yeah.
And then this would be the,
As
okay.
long as you use the correct formula, master, that looks good, yes. Read it, son.
Calculation
PBI2.
Okay.
Yep. Who's that? Okay. Well, here's what I'm gonna do. I'm gonna give you this slide, or this card. Okay. What we're doing is we're doing these 3 calculations for the information that you're given on here. So grab a sheet of paper and I'll show you what to do.
Right? Over the molar? Right?
Wait, so it's literally the same thing as the first problem.
So then, Mr. Brand,
The ratio.
Yes.
so you know how we have to do it with the lead nitrate?
Yep.
Are we we're still finding it for the amount of lead iodide produced, right? Lead iodide.
Yes, because that is the precipitate. So we're always going to these.
Okay.
The only additional calculation that I'm asking you to make is to find the moles of lead nitrate. Okay? And then you would do these 2 as well for this one. Okay? So you've got a volume you've got a molarity. The second one, this one here, the volume is differing depending on your group. Okay? So some of you have 5 milliliters, some of you have 10, some of you have 15, some of you have 20, some of you have 25. So for this one, your numbers should be different than the people around you. For that one over there, your numbers should be the exact same for every group in this room. Because we're working with the same amounts for that one. Okay?
So we have 10 milliliters, so do we actually have to do this in a separate?
Well, you do, because if I'm not mistaken, the ratio is not the same for the second one, the NaI, compared to the lead iodide as it was for the lead nitrate compared to the lead iodide.
What do you mean?
Well, look at the ratio table. Yeah? So you're telling me this is the same as this?
Well, I'm saying that the formula is the exact same as it was before.
Which formula? No, I'm telling you they're not. Because I'm telling you, this ratio that you used in the ratio step to get the moles of this is different than this ratio. That's what I'm saying to you. The calculation should be similar. Yes. Okay.
Thank you.
So what we're starting by doing is we all got 10 milliliters of this solution.
No, we went from the end of 3 to
Okay. So I'm asking you to find 3 things about this. Take the volume times the molarity and get this. How many moles of lead nitrate there are here. Okay? Then use your ratio step, the second step we do in our problems, to figure out how many moles of lead iodide would be produced. Okay? And then finally convert that into grams. Okay? Now, when you're done doing that for this, we're going to do it for this, but on your blue card, you have a different amount, a different volume here than the other groups around you. Okay? So you're going to take this, your volume here, and you're going to, again, find how many moles of this you're starting out with, how many moles of this you would produce, and finally, how many grams of this you would produce. Okay? So you need to do those 3 calculations for both things.
Nothing to do with actual class. Yeah.
Yes.
Is this right?
She teaches the child development class. She used to be this. She used to be
Can I
the teen
ask
parent.
which one we're talking about?
The teen parent teacher. Because we used to have a class like specifically for.
That's not the moles of this. That is the moles of this. Because you've gone through your ratio.
Oh, am I supposed to be doing this?
But
Let's share with everyone.
Now, if you stop before you get to that ratio step,
I don't know if I'm supposed to be
these
doing
two will give you the moles of
this.
this.
Oh, so then,
Okay? So basically, ladies and gentlemen, we normally don't stop after every step. But what I'm asking you to do is take what you're given, find me the moles. Just the moles of your reactant. Then use the ratio step to find the moles of product. Then finally, find the grams of product by taking the moles of product using the formula mass to get to grams. All things you have been doing.
But you just want us to write down our answers in
The old, I'm sorry?
You want us to write down our answers in between? You don't want us to do it all in one step?
Well, because I want this. Normally, we would do this all as one calculation all the way through. You are correct. But what I want you to do is stop after each one and get me an answer, because we're going to need to put it into our table in just a minute. Okay? So yes, same calculation we would normally do. Take what you're given, get it into moles, use the ratio, and then report out in your final answer. But what I'm asking you to do is each step along the way, stop and give me a number after each step. After you get it into moles, give me an answer. After you do the ratio, give me an answer. And then when you get into grams, give me an answer. Now, Please remember, KP, you told us earlier, the reason we're doing this for both is why? So, when you get to the number of moles of lead iodide from this, it may be different than the moles you get from here. Which one can you make? In a limiting reactant, you can only make the which amount? The smaller. So the same way, your grams of iodide produced from here might be different than from here. You can only make the smaller amount, but I still want you to find how many grams would be produced in each. Fair enough? Questions? Okay, let's go, because in a minute I'm going to need you to put them into a table for me.
Okay.
We're putting it in the table. Dude, what do you mean share with
Well, there's only one way to cancel out liters with polarity. And what are you beginning with?
That's the lab, and then we're not doing that today.
What do you have that is different than everybody else? What's
We're doing the table.
okay, then begin with liters. And there's only one way to put polarity to get out of liters and into moles. You want your liters to cancel, you want to be left with moles.
Wait, no, I didn't. I lied. Yes, I did. That was
I think I got.
Do I need to put it? I
Okay.
don't think it's supposed to be
Okay.
continue.
Actually, grasped it a little bit. It's happening. The question wrong on our quiz because I took it the
Just tell me you appreciate it.
You can start with the ones that ain't being used.
so I don't think
You
I
guys are here.
That makes sense. That makes sense to me. Hey,
Because
first time I'm literally ever grasping any question. That's pretty good.
I appreciate you.
And
You
then
got all your numbers
what
done?
is 1.6?
I gotta do the whole.
No way.
That's not right. It's gotta be right.
Okay, 461.
It's not right.
What's the?
Mine are really
Yeah,
big.
it's gotta be right. There's no. No.
Wait,
And
we
then
all have the same like level.
That's 20 milliliters.
Okay.
Let Mr. Archie clean his chalkboard.
Yeah.
20
Yeah.
divided by 1,000.
Might we use this ratio from?
Oh my, it's 0.02, not
It worked
0.02.
really well though.
Wait,
I
so
got
my
one
number-
that was spotless.
Really? Maybe you want to copy it down correctly
Yeah.
then.
I don't do
Because
that.
No,
that's
why
not
why
the
is the
That
2
is
at the
Mr.
front?
that I have.
Why is the 2 at the front?
Yes.
Oh my god.
I was gonna tell you.
Sure, I'll have the same thing.
No, it's 0.02, right?
Oh, the line 9.
That section. We should all have the
0.02.
same numbers.
Okay, so not the one we're doing right now.
Right,
Okay,
good.
so
It's 0.02,
That's fine.
it's 0.02.
we're doing something else.
You can throw the
That's
millimeters
fine.
in.
What?
What did I do?
You said EVF?
This doesn't seem right.
Yeah, like you start with the liters. then
Everything here.
0.007 times 460.
500. And you
You
convert
so
that
cute
into
with short
liters.
hair.
460.
Like right here.
And then you divide it by 1 liter.
So basically
and then
it's
you
a
put
phase that goes to
0.500 moles on top of it.
Oh, it's 2.
And
Okay. Okay.
But you have to put 1 instead of just.
Now,
yes,
the other one here.
As
You
long as it's
got
like
it
up
in
to
the
4
moles. Now do the same
Everyone
thing
was like,
and
what's
into
the
this.
Bro, you want
This,
to
let's
done.
see.
Okay,
Which
wait.
of these two is smaller?
My guess is gonna change.
0.000.
Well, you got that in the moles.
Okay.
It was
Now,
just like,
let's
look
take
at
it out of
it.
moles.
So bad, but I didn't
Let's
say
get
it.
into moles of lead iodide. You get it? Using the ratio.
On what, the first one?
Okay?
Just see which
Just
one.
need to see which one is the smaller
For the
amount,
first problem,
and then let's go all the way to grams.
Times
and just
461.
That's
3305.
the, sorry.
So you just need to
Yeah,
finish
yeah,
up
it's
your
for the
number.
first one.
Like 3 times
Because they're both 15.
For the first one, I
We're
got the same
missing 2
thing.
moles of this.
and then take the whole of this that you get whatever number it is and take it
Yeah, we did it.
502 grams.
But now we have
But I
to.
got the same
I guess we have to do the same
So
thing.
you're gonna take this number and start again.
Like it was so
Do the
nice.
calculation, you change the ratio, you're no longer in you're now in PBL.
See, bro, I've been done already.
Yes, yes. As soon as you're done with all your calculations, yes.
Yeah, I got the huge.
Okay, so where'd you get this? Oh, 0.2.
I got the first one.
0.2.
So that's
I was right at first. I don't know why.
Don't use that. Okay, so what we're gonna do is you're gonna take this volume, okay, times that molarity, 0.500.
Unless you get super short later.
That's what you're gonna take it times. That will get you to the moles of each of those things. Alright? Okay?
What's the molarity for?
They're both the same, 0.500.
Both polarities are the same, ladies and gentlemen.
That's fine.
I really need to cut off the ends because they're so bad.
So now you have
No, you look at
Oh, yeah.
No way this is right.
Ever had those moments where you feel like it's that till you wake up the next morning? Get out my jeans.
Oh my God.
You go to bed the whole day till it's
I
good.
told Coach that you're stressing me out. You're
Well,
more
no, you're
Ron, please tell me that, bro.
So you're just picking over there.
There's two of that.
Three.
Two of that. Yo, it's like it's invisible.
Molarity
0.02.
times volume gets you in the mole. Molarity times volume gets you in the mole.
No, who's writing all that?
You're taking, where do you?
Oh, so we're doing this.
Let you do it.
Well, we're also going to get the same answer. So we asked Sophia.
Volume
Yeah, Sophia.
times the molarity, 0.500.
Well, yeah, it's polarity.
Oh, it was cool.
Okay.
Wait, what moles? What the moles of what do we?
Because I got a really smaller one.
It's gotta be the smaller one.
Yeah.
Remember, you only make the smaller ones.
Yeah,
Yeah.
0.005.
I don't know. Yo, Farhan, fix it.
Oh wait, yes, it says that. Because you have 25, that's why.
Yo, fix it.
Then it's not safe, you don't have.
No, we're doing lead nitrate.
Yeah, 0.
Oh, I was
Yes.
Okay, thank God. I was like, fuck.
And one of us is right, one of us is wrong.
Okay.
But yeah, I mean, I'm just gonna do the
It
short
was
hair.
1.0. I'm still on this.
And like when I say short,
It's
I mean, I'm
definitely
just gonna cut off.
Oh, okay, so
like,
it's like,
It's definitely not
the
one.
top is gonna get
It could be one.
I'm only gonna cut off like this much.
You got this, but mine's not touching.
You'd be cute.
Not even close. One is not even close.
I had that.
Well, this is a half 0.5 molarity. 0.5 moles per liter. It would take 2 liters to get to 1 mole. 2 liters. You're working with 10 to 30 milliliters. Should be a small number.
0.00.
I was right. It's 0.0.
It's a lead nitrate, bro.
Okay, ladies and gentlemen, when you get your results, here is where they need to go. You need to start putting them in this table, ladies and gentlemen. And if someone messes up and puts the wrong numbers in here, and you have that same volume, fix them. Fix them, because when this is done, it needs to be right. But here's what I'm telling you. You are doing all of the calculations that need to be done after the lab ahead of time. So if you're not getting this right, you better figure out what you're doing wrong, because otherwise when you go to do the calculations and actually put them in your lab, they're going to be wrong, and I'm going to mark them wrong.
So the first one is the first step, the second one is the
First step, yes. And then this is a combination of the next two, because remember, I only want the smaller amount of moles made. You figured out the moles made by the sodium iodine and by the lead nitrate. We only want the smaller amount of those two. and then the smaller amount of grams as well.
Yeah, trials coming up. Oh, Farhan, this might not be ready, Farhan. Why do we have an extra 0?
You put that there. I don't put that there. It's all yours.
Ooh, the decimal point might be off.
It's
Hey, Farhan, the decimal point.
That's the only one who put the grams in.
Oh, so we don't need the grams of this?
No. You're finding the grams of this product. So from this many moles of this, you need to work it to the 2 grams of that.
Okay.
Is your calculations done?
But I thought we were doing.
Oh, Farhan. Oh, we messed up on.
We are. So we take this.
Oh, we messed up on.
Right?
This is the wrong
Then we do the
decimal
ratios, correct? Then after the ratios, what we do is we have to get it into grams.
Bro, just wait.
This step from here on, this step is the same in both problems because you're still going to the same problem.
Oh.
You decided to go to the other product. We're always going to this product so we can compare and say which one we make more.
Oh.
Okay.
Okay. Okay.
No, we're at and I was like,
Good?
Yeah.
a little silly.
If he's talking PV equals nRT on this problem, ignore the headline because he's confused. There's no gases here. Where do you see gas?
I'm gonna actually like mess up that money.
Apparently it's talent, pure and simple.
I don't know about that.
What? Correct. Correct. Yes, you do. 0.500 moles. They're both the same. Molarities are the same.
So we do the same thing, yeah.
So you ever
Okay. But then when you go to the moles of lead iodide, they will be different because the ratios are different. It will be. Here's the standard. What? Now we can do what part?
You don't know what you're talking about.
Well, you have to figure out the ratio and you have to
You have no idea what you're talking about, bro.
He's so pressed out.
You don't know what you're talking about, buddy.
We got it?
It's JB, bro. Don't worry about it.
That
So let's,
psychology and deal with Mr.
go in the first column, multiples. Now, we're gonna go on these.
I have a talking teacher for economics.
Wait, everybody got
Okay. Because now when we get down to this, now this is an extra because it makes a larger amount. This is limiting.
Moles of lead.
Oh, for lead nitrate, yeah.
No, they, I saw them.
Right? That's what we got. That's what we got.
No, because it's already
Why
labeled
did you
up
put
top.
that there?
Okay, by the way, if you put numbers, hey, if you put numbers into the table, take all your units out. You cannot put units with these numbers because either in Excel or in Google Sheet, if you put units by a number in a table, it will not be able to graph them. Okay? It will not be able to graph them. So, ladies and gentlemen, like here, I appreciate the grams of PBI, but it's already labeled up here. Moles and mass of precipitate. It's already labeled. Moles, grams. You do not need to put units here. So you need to take that out. Otherwise, it will not be able to graph this when we need to graph it eventually. Okay?
It's either this or this. I don't know. Which one? The lesser one?
You can only make the smaller amount. Ever. That's all you can ever make. Okay.
That's something I hate about track. Is that like if
We have a problem with this calculation. Take 0.025
I just made that
times
up.
0.5.
That's up.
That's what
maybe you should do your method.
You made that up.
Well, I only do certain methods for teams, right? Like they don't do all of them all the time. Well, certain methods.
So that's this. Okay.
What did
Now,
you say? What did you
exact times 1 divided by 2. Or just divided by 2.
Oh, they're a crazy number.
Okay. Alright, now take that times 461. Okay, 2.88.
What is
Good.
another one?
Now let's go down here. Take 0.1 times 0.5. 0.01, I'm sorry.
Oh, but I
I'm
didn't
getting
tell.
0.0075.
What's it? I should tell you.
Okay. Why'd you put a 2 there?
Oh, no,
I was from the
Oh,
so
from
you
the-
can let's change that to a 1.
That's from the-
Now, that means that this number
divided by the 2.
take it. Okay, so now this goes all the way out to here. You see why? Because this is 1 to 1. So take this and plug it in here times 461. Take that number times 461.
Because this one was the one for about.
Okay. Yes.
That is wrong, like, twice. That's
why that's on the
Oh,
bottom.
but it's okay. Okay, so instead of that, we have point.
Now you're doing the other equation. This is what's supposed to be there.
Holy, that's a lot of lyrics.
Yeah, it was a 6 minute. This was expected.
Oh, are we using?
I just think-
Go to the drink.
My disc was always like 2.5
My house
minutes.
right now. He asked me like, your guys' daughters are so.
Well, you should have the same number of stations.
You know what he said?
I'm not gonna do anything with it. Yeah. He like sounded fertilized.
Yo, that guy's real. Yo,
My
that's
mom
real.
didn't really want to do all this, I really care. But he wants to.
Oh, there we go, another. That's another one. Putting money for us. I'm
He's
bugging you
so
with the work more.
Oh, this is the wrong song.
Oh, that's 60.
That's a whole wrong song. Too. That's the whole wrong one.
Thing that happens to
This is the wrong one? Okay, address the allegations controversial address the right
All of a sudden,
Like, I also
because now instead of being the sodium lead nitrate, that's a chain reaction.
I'm taking it to myself now. Maybe I am wrong. Wait, which one's yours? The 15.
Looks good. Now where's your calculation for this though?
I'm a war general season and preparation.
Yes, it did. It asked you to do the same thing for both.
It asked for the water for a week and then we fed
It asked for the moles, then it asked for how many moles of this would be produced from this, and then it asked how many grams of this would be produced from this.
Can we see that?
That thing, what thing?
The thing having the screen with this.
Did you?
Yes.
Somebody take the symbol. Who has the 10 and 10? Take out the labels on the numbers, please. There you go.
What was that? He said it again.
Yes.
Right there. How many moles of NaI? How many moles of PBI2 would be produced from that many moles of NaI? And then how many grams would be produced?
You're a hater, Ebro.
That'd be the same thing as this.
No, it isn't going to be the same thing as this because your ratio is not the same. Because the ratio is different, it's going to change things. Even if you begin with the same amount and even if you have the same molarity, it's going to change because your ratio step here is going to be a different ratio than it is with this one.
All we're doing is just ratio.
That's
Ratio.
Again, you're answering these three questions. Find me the moles of NaI based on your volume and your molarity. Then take and figure out how many moles of this would be produced. Then take and figure out how many grams would be produced. Okay? So that's what we're asking you for.
I don't know why.
Yeah, you don't
I think the most
Should I hop on that beat, bro?
He said, oh, okay, this is what
He said whoever makes the best song with this beat gets
Yo,
a free
listen
beat.
to this, listen to this, listen to this.
You don't think Metro Boomin wants to give me a free beat?
Oh, you're not making a verse song.
You sure?
Okay.
You're not making a verse song.
What's the matter?
Yo, listen to this.
Trying to find the number of that. But how do you get that? Oh my gosh, it's like Kendrick Drake.
Well, the amount of lead iodide is the same as first.
Yeah.
Is the amount of grams produced from lead iodide the same.
You didn't hear Kendrick's new song?
Okay, here's the thing. You got that from this up here, right? But down here,
I remember that kid.
how many
I'm
moles
listening to that
of this
together
did you
again.
get from this
Yo,
calculation?
don't pull that video up. Gosh, it's not good.
Before we
I'm
use
sorry,
this
that
stuff?
was
No, thank you.
I don't
That-
know.
Yeah, I have the message today. It's actually him.
A minor.
Yeah, up with that one.
That's the number you should put in there. This is the word.
No way, that's him.
Make this amount. You run out and you make this amount.
After we get.
So please change that. Okay?
After the last step? After the third step?
8 or 19 Dre versus Kendrick.
Show it to me.
Bro, there's no video proof. That actually might be proof.
What are they beefing
The could be up there.
They've been beefing for like 10 years now.
What?
Yeah, they took that
Well,
other
okay,
video.
so apparently it started because so it was back in like
It's
2019
BL rings.
and J. Cole
That's your
were
final
both
step.
on top.
And then the
It's
moles.
that, bro, they're not gonna show
Kendrick is still on the top, you know?
Right here, I'll put a check mark by it.
And
And then
apparently
No, it's not there. You don't have to hold last
after
time.
your molar ratio there,
Rise to the
and
top.
then your moles,
And
the
then
first
started
one
using
is right here.
Okay, please listen, ladies and gentlemen.
There's a second problem. There's two problems.
Close your computer so you'll give me your attention, please. Close them all the way. All the way. Close your lids. Then I know you're not going to be tempted to look down and look at other things. And then I know you're going to be listening to me because this is the stuff that I'm going to tell you today so you will get your lab finished tomorrow. Okay? Now, first of all, ladies and gentlemen, what you have done is you have done the calculations for your lab, which is good because you're going to need to put them into your lab. Okay? So the calculations that you just did to get these numbers, ladies and gentlemen, in your... Can you change that?
We did, but it's just not showing up.
Okay, let me update. Thank you. There we go. Okay, so now, ladies and gentlemen, these are the questions. These are the answers to all the calculations that are going to be in your lab. Now, you're going to need to show me an example of the volume that you had. Okay? But then under the question, it's going to ask, well, what were the other moles of lead iodide that were created? Here they are. It's going to ask you how many grams of lead iodide were created. Here they are. Now, what do you notice that is weird about those numbers, ladies and gentlemen? Especially the mass of precipitate. The last three are the same. Someone tell me why. at the beginning, the reason we could only make 0.576 and 1.15 and 1.73, which of these two was the limiting reactant? Somebody who had 5, 10, or 15? The sodium iodide was limiting at the start. Okay? So that's why we could only make these amounts. And at the end, which one became limiting? The lead nitrate did. So we're going up, up, up with our precipitate, and then it levels off. Why? This volume continues to increase. This one doesn't. As soon as this one becomes the limiting reactant, I don't care how much more of this stuff you're adding, it isn't going to change it. It levels off. Questions? Okay. Open up the actual lab, ladies and gentlemen, and look at the lab. Okay? Now, first thing that you are going to do tomorrow is you are going to clean and dry a 150 milliliter beaker. After you clean and dry it, ladies and gentlemen, you're going to take a chalk marker and you're going to put your name on it. Okay, you're going to put your name on it. Hang on one second, please. You're going to put your name on it because you're going to need to come back to this on Wednesday and identify your sample. So you're going to put your name on it, yes. Then your partner is going to have to do this for you. Okay? And you can get the information from them. Okay? So, sorry, but there's no other way to do it. You're not going to have time to finish it and dry it overnight. Your partner is going to have to finish for you. Okay? All right. So now, ladies and gentlemen, what you are going to do is you are going to take and you are going to mix these two chemicals together in this beaker. Now, to do that, ladies and gentlemen, you're using a piece of equipment probably none of you have ever used before. This is called a pipette and a pipette bulb. And what this does, ladies and gentlemen, is this will suck up the solution from your container and allow you to carefully transfer it into the other one. But this is also marked out, ladies and gentlemen, in markings. This tube will hold 10 milliliters of whatever solution you want when you go up to the 0 mark at the top here. Now, because this is such a narrow tube, that means you're going to be able to read your meniscus a lot better, and you're going to be able to get exactly the amount you want in here. Now, the way this begins is you take this bulb at the top and you squeeze it. And you take all the air that's in there out of it. Now, tomorrow, contamination is a problem in this lab, so make sure the red bulb and pipette only goes into the solution marked in red, which is the NaI. Okay? Now, depending on your volume of NaI, you may have to do this up to 3 times if you are the 30. You may have to do it 2.5 times if you're the 25. Okay? If you're the 5, you're only going to pull this up to the 5 mark on here. Now, the numbers are upside down on here. Okay? And the number 9 is on the bottom here, but there's space left after it. That is the last milliliter in here. So these are what we call 2 empty pipettes. In other words, if I pull this up to 0, I'm going to dispense 10 milliliters into whatever container I want it to. So if you need 20, you're going to do it twice with this one. Here's how it works. You're going to take and you're going to put it into the container with the sodium iodide in it. And you are going to press the button on the side here that has the arrow that goes up. And what it is going to do is it is going to pull solution up into your pipette until you get exactly where you want. If you take in too much, there is an arrow on the side here that points downward. If you press it, it will let a little bit out. When you get exactly 10, you take it over to your glass, you hold it above, and you hit the downward arrow to dispense it into there. And you go all the way until it will not come out anymore. That will be 10 milliliters. If you need to do this twice, you do this twice. If you now need to add 5 more, you add 5 more.
You look great.
Well, of course.
Happy Teacher Appreciation Week. We have snacks. And you're right in the middle of a lab, right? You're going into a lab. See?
Should we just
That's what
throw
I do.
things at him?
Yes, please.
What kind of snacks do you want? Protein or just garbage? Garbage.
He's all ready.
See?
Do you want
Everybody-
Gatorade, water, or seltzer if you'd like one of those?
Oh, no, because it's not iced tea. I'm not drinking
Okay.
it during the day.
Oh, I
Thank you.
almost picked up iced tea too.
It's okay. It's okay. I'm
Now
good.
I know.
I'm good. So,
That one right there, if it's causing you any problems, you let me know.
are you kidding? She is the best student who sits in that seat all hour. All hour.
Watch my big foot.
That's crazy.
All of this? You're kidding. That's a haul.
Well, we gave him gum so that way that would help.
They're not close enough to know if my breath is bad or not. Thank
Sorry,
you.
guys. Sorry to interrupt.
Thank you. When you're done with the red, put it down and leave it. Put the cover back on. And I'm not putting the cover on tight. I'm just putting it on top. Now, how much lead nitrate do we all use?
10.
We all use 10. Now, this one is a little bit different. The way this one works, ladies and gentlemen, is you hold this in here and you see the wheel at the top? If you twirl that wheel, it will pull the solution up as you do so. And again, we want to get exactly 10. When you have exactly 10, you pick it up, carry it over to your container, and then you hit the top of this lever on the side, and it will dispense it.
Oh my god, it's yellow. That's
Yep.
crazy.
Boom. Done with that. Put it back on the same paper it was and leave it. So these will be sitting on one sheet of paper, one sheet of paper towel at your station, so we don't accidentally mix them up. Red with the red, green with the green. Okay? You have just now created, ladies and gentlemen, this stuff. This is the precipitate. This is the yellow stuff in the bottom. These ions are floating around in there. We want to get just this precipitate and not these ions. So now we have to go through a process to separate them. Here is what you are going to do. You are going to take a piece of filter paper that you have already found the mass. You found the mass of this container. You're now going to find the mass of this filter paper, because between this container and this filter paper, that is where all of the precipitate is going to end up in the end. All of it. Now what you do to this filter paper is you fold it in half twice. So once to where it looks like a half circle, and twice to where it looks like a quarter circle. You then put it inside the funnel, and you take 3 of the folds and pull them one way, and 1 goes the other. Okay? If you do 2 and 2, you're going to have a big old hole down the center. 3 come to one side, 1 goes to the other. You take a water bottle and you wet the filter paper down so that it will stay in place nice and firmly while you are filtering this. That you can do at any time after you take the mass. Okay? Now, what I'm letting happen here, ladies and gentlemen, is I'm letting the precipitate settle to the bottom because it's heavier, it's a solid, and I'm letting the solution hang out on the top. And now we're going to do a process called decanting, which is I'm going to try to pour as much of the liquid off without getting the big heavy solids at the bottom. Why? If I put the heavy solids in here right away, it will plug up the filter paper. Or worse, some of them will make it through the filter paper and start going through into the bottom. Then you have to refilter that whole thing again. And you have to get another piece of filter paper and refilter it. Because all the yellow stuff needs to stay in here. Okay? So after a few minutes, ladies and gentlemen, and by the way, you're going to be making observations of the things before you begin, of this stuff, the wet residue. You're going to be making observations of it. Now, when some is sitting on the bottom, I'm going to start this process called decanting. I'm going to gently pour off some of the liquid on the top into the container. And right away, I got yellow in the bottom, which means I would have to grab another piece of filter paper and do it again. Okay? So again, it's not a good idea to play with the filter paper after you fold it like I did. So worst case scenario, there will be extra bottles sitting on the back. There will be extra funnels. You will have to grab another piece of filter paper and you will have to mass it. Because again, you're going to subtract the mass of all the filter papers. If you use 2 filter papers, if you use 3, whatever. Actually, ladies and gentlemen, never mind. That stuff is still clean. I'm good. Okay? Now, when you get to the point where there's only a little bit of liquid left in here, you're going to take your bottle, your wash bottle, and you are going to add more to it. And then you're going to take and swirl it around a little. Why are we doing that? What's that? Well, we need to get this stuff out of here. Okay? We want to leave this stuff behind. This is going to take 2 or 3 rinses. Now, if you have a very small volume of NaI, if you only have 5 milliliters, you're going to be able to rinse this probably 4 or 5 times. Why? You don't have a lot in there. But if you add the 30 milliliters, you have a lot in there. So you're going to try to let it settle to the bottom, and then you're going to pour off the liquid off the top. Then you're going to add more liquid, swirl it around. Now, I don't want to add a ton of liquid. Why? I got to get rid of it. I got to get rid of it. But I need to add some so that I can get those ions mixed into more water so that I get rid of more of these ions that are left laying in there. So the balance is I want to get rid of these, okay, but I don't want to take forever doing this lab. Okay? So now again, as this sits, the solids are going down to the bottom. There's a clear level of liquid on the top, or clear. I'm going to start pouring it out. As I'm pouring it, ladies and gentlemen, a little bit of the yellow in with it is fine, but as that heavy yellow on the side starts making its way toward the edge, I don't let it go out of the container. So all of this stuff started working its way to the edge, and before it dumped out, I put it back this way. Again, rinse it down again. A little bit.
How do you know when it's like that?
You don't.
Oh.
There's no way of knowing. It's not like it suddenly changes color or something like that. So you want to do as many rinses as you have time for so that you get rid of as many ions as possible. Because in the end, we're going to see how good a job you did. Because in this table, ladies and gentlemen, everyone is going to put their results. So I'm going to have 2 numbers for a lot of these. Okay? 2 numbers for a lot of these. Some there may only be 1. So guess what? If you mess it up, you're messing it up for the whole class. Okay? Then we're going to get a class average for these 2 numbers together. Then when my 4th hour does it, we're going to get an all-class average over here for how much was created. We're going to see how you do as a class, and then as an all-class, and as an individual. Okay? Now, this is how much you should get. It's not a lot, really. Okay? But we're going to see how well you do. So again, ladies and gentlemen, This is dripping through. My filter paper looks like it's empty inside. I'm going to take and I'm going to pour a little bit more out of here. And when the heavy stuff starts to get near the edge, tilt it back. Now, eventually, ladies and gentlemen, you're going to have to stop. We're going to be out of time. When we get to that point, you want as little water in here as you can. Hope that nothing in here is yellow. And we're going to take that filter paper, throw it in here, and put it in the drying oven overnight. And then when you come back the next day, we will look at what that looks like. And I will be able to show you in class tomorrow what mine looks like because I'll dry it overnight for you. So that way you'll have an idea of what it's going to look like. Questions? Now, you need goggles for the lab. If you want to wear lab aprons, you are welcome to, okay? But again, you need to come in. We'll go over a couple of things, and then we will get you going right away. Why? Because you need as much time as you can to decant and filter and separate this stuff out. And the more times you can filter it, the more times you can decant it, the better off we are going to be. Now, all of the calculations, yes, bring me these cards. I hope you wrote down what color you have for tomorrow. Bring these cards up and put them up here. If you want to take a look at anything that's up here, you are welcome to.